All right, guys, welcome back. Here is video 2. And on page 2, really this page is about one major concept. It is about SOHCAHTOA. So, SOHCAHTOA. Again, that is sine is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. Tangent is equal to opposite over adjacent. Keeping that in mind throughout this entire process, let's take a look at number 3. It wants us to just write the ratios. The ratio meaning a side divided by another side. So as I can see in part A, it says I'm dealing with angle A. So here is angle A. So I'll label my sides. 6 is opposite, 10 is the hypotenuse, and 8 is the adjacent side. So if I want to do the sine of A, the sine is opposite over hypotenuse. So in this case, I have 6 is the opposite, 10 is the hypotenuse. And that reduces down to 6 over 10, both divisible by 2, so 3 over 5. So your final answer there is 3/5. For part B, it wants us to find the cosine now of A. Cosine is adjacent over hypotenuse, which is 8 over 10, which reduces to 4 over 5. And then part C wants the tangent. Tangent is opposite over adjacent, so 6 over 8. Opposite side over the adjacent side. And 6 over 8 reduces to 3 over 4. Now for part D here, you'll notice that it says the sine of B. So I have a new angle, which means I'm going to erase everything off that triangle. If now I'm talking about angle B, my sides are relabeled. So opposite of B is 8. The hypotenuse in this case is still 10. And the adjacent is now 6. So if I want the sine of B, the opposite is 8. Over top of the hypotenuse, which is 10, which reduces to 4 over 5. So that one is also 4 over 5. You may have remembered from our last section that the cosine of A is equal to the sine of B. You may have remembered that. All right, number 4 says use trig ratios to find the value of x, round to the nearest tenth for sides, and the nearest degree for angles. Okay, so number 4. Here's my angle, 72. So I'll label my sides, opposite, hypotenuse, and adjacent. Determine which side is not. I have no information. My useless side, we were calling it, and O is useless. So I have A and H. A and H mean I'm going to do cosine. So cosine of the angle, which is 72, is equal to adjacent, 10, over hypotenuse, x. This is one of those situations where when we have x in the denominator, we have the old switcheroo. So I'm going to switch the cosine of 72 with my x. So this becomes x equals 10 divided by the cosine of 72. That's going right into my calculator. Make sure your calculator is in degree mode. Right? Do not make the mistake of leaving your calculator in radians. Make sure it is in degree mode. And I do 10 divided by cosine of 72 right in the calculator, rounded to 1 decimal point is 32.4. So is the hypotenuse, does it seem reasonable that it could be 32.4 units? As I look at the short leg, it looks like is 10, so 32.4 does not seem too far-fetched. Number 4, my angle here is 75. So I have my opposite, hypotenuse, adjacent. The useless side here is H. There's nothing over there. So O and A is going to be the tangent. So the tangent of the angle, 75, is equal to the opposite, x, over the adjacent, 22. To get x by itself, I have to multiply both sides by 22. So 22 times the tangent of 75 equals x. Type that directly into your calculator. 22 times tangent of 75, round to 1 decimal point, and x is equal to 82.1. So 82.1. If I look at this triangle, 22, so it's about 4 times as long. Yeah, I guess 82 doesn't seem too unreasonable. If I would have gotten a number like 5,000, all right, that would have really thrown up a red flag. But that seems to be pretty reasonable. Number 6, here's my angle, so my opposite, hypotenuse, and adjacent. The useless one here is adjacent. So O and H is sine. So the sine of x degrees is equal to the opposite 4 over the hypotenuse 14. Now to solve for x, I have to get rid of sine. And I get rid of sine by using that sine inverse. Sine to the -1. If you're using a TI graphing calculator, it is second than the sine button. And I'll type in 4 over 14. So your calculator, and we want to round this to the nearest degree, the nearest whole degree. So when I do the inverse sine, 4 over 14 and round it to the nearest degree, it rounds to 17 degrees. Okay, and number 7, last one on this page, says name at least 3 Pythagorean triples. There are a bunch. They just have to satisfy a squared plus b squared equals c squared. The 3 most common are 3, 4, 5, or any multiple of 3, 4, 5, like 6, 8, 10, or 9, 12, 15. Those are all 3, 4, 5 triangles. We have 5, 12, 13. We have 7, 24, 25. And again, if you watch the video on the little trick, you can really pick any number you want. You can pick the number, I don't know, let's say 8. 8 is even, so I cut it in half. Half of 8 is 4. 4 squared is 16. So I go 1 below and 1 above. 8, 15, 17 is one of them. I could do 9. And when I do 9, it's odd, so I square it first. 9 squared is 81. Half of 81 is 40.5. So that's 40 and 41. The integers on either side. So I don't care if you use the traditional ones or if you want to find some extra ones by doing the little trick. I will double check to make sure it is an actual Pythagorean triple, however. Remember, that means it has to be they all have to be integers. A plus b has to be greater than c, and a squared plus b squared has to equal c squared. That's it for video 2. We're on to video 3.